All right, welcome to the video for lesson number 11. So in this lesson, we learned about common tangents and some of the different relationships that come up with that. So all the math rules that we know about circles are still going to come into play here. So let's talk about the first one. So the first one says that QP is 18. If QP is 18, I know already that PT is 18 because those are two tangents tangent to the same circle at the same point. Well, if I know PT is 18, I also know PR is 18 because they're also tangents to a different circle at the same point. So to explain your response here for what the length of PR is, you can say PR is 18 because PR and PT are both tangent to the same point, and PT and QP are both tangent to the same point. Therefore, they're all the same. Number two gives us this situation. So it gives us these triangles. We see some angles are given. So ACB is an angle of 60 degrees. And then it says that they want us to find PR if PA is 1.25 feet and 8 inches. Well, notice one thing for sure. One of these is in terms of feet. One of them is in terms of inches. So we have to either convert feet to inches or inches to feet. I'm going to convert feet to inches by multiplying 1.25 times 12. So we'll say this is the same as 15 inches. So let's label everything we know. So I know if angle ACB is 60, because of these tangents being congruent, these radii being congruent, and these angles being congruent, these are the same size triangle. Therefore, each of these small angles is 30. Same thing's going to happen on the other side. Because of vertical angles, I know these are also 30. Also, because these are 90-degree angles here, 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 and here, because they're where a radius intersects a tangent, I know these angles are 60. So I actually know a lot about this picture before I even label any sides. It then says that PA is 15 inches, which means PB is 15 inches. And then it says RD is 8 inches, which means RE is 8 inches. And it wants us to find PR. Now notice PR is PC and CR. So I'm going to make each one of those parts a different variable, X and Y. Now, one thing that I notice about these triangles is they're similar to each other. So I know that they're similar to each other. I also see that I have some trigonometry that I could be using here. So if I look at just one of these triangles here for a second, so if I just take out triangle PAC, I have an angle of 30. I have a side of 15. I have a right angle. I have a side of 60. And I have a side I don't know. So if I use trigonometry here, I can find the length of PC. 15 is the opposite side. PC is the hypotenuse side. So I can do the sine of 30 is equal to 15 over x. Remember, to solve that, we're going to multiply both sides by x. So I have x times the sine of 30 is equal to 15, and then divide both sides by the sine of 30. And I get x equals 30. So that means the distance from P to C is 30. Now, if the distance from P to C is 30, I now have to find the distance from C to R. I don't know why that happened. So from P to C, we have 30. Now, there are two ways of me finding the distance from C to R. I can use trigonometry again, which is how I'm going to do it so we could practice that skill. Or because these are similar triangles, I could set up a proportion and say 15 compares to 8 the same way that 30 compares to y and see what we get. Actually, you know what? Let's use the similar triangle one instead of trigonometry. We've been doing a lot of trig lately. So I like that. So let's take a look at these two similar triangles. So I see that 15 is a radius and 8 is a radius. So I can say radius compares to radius the same way that PC, which we've just found out was 30, compares to y, which we don't know. Cross multiply, I get 15y is equal to 8 times 30, which is 240. Divide both sides by 15, and I get y is 16. Now y, remember, was the distance from C to R. So I now know the distance from P to C and from C to R. So the distance from P to R is going to be the sum of those two. So it would be 46 inches. Now this is one of those cases where I'd say I would want you to actually write the units, because this problem had feet and inches in it. So we want to be able to clearly say what this is, unless it asks you to determine the length of PR in inches or in feet. Two more. So for number 3, it says the perimeter is 30, and it says find the measure of AP. Well, in this picture, I see some tangents that are tangent to the same point. So because of that, I can label some things here that I don't have labeled in the picture. If RC is 4, I know QC is 4. I know if BQ is 6, I know BP is 6. I don't know AP and I don't know AR, but I do know that they're the same. So I'm going to make them both X. Now, all of the sides in total add up to 30. So I could say the perimeter is equal to 6 plus 6 plus 4 plus 4 plus x plus x. I'm just adding up all the pieces around the edges of my circle of my triangle. So the perimeter of 30 is equal to 20 plus 2x. Subtract 20 on both sides. I get 10 equals 2x. So then I get a value of x, which is 5. So that means AP is 5. Last problem. Last problem says determine if segment AB is tangent to the circle. Hint, remember, a radius must be perpendicular to the tangent. So one of the things that we know is that any radius is going to be perpendicular to any tangent. So to determine if AB is truly a tangent or not, I just have to prove that this is a right triangle. To prove something's a right triangle, I can prove that the Pythagorean theorem works. So in this picture, I see this segment is 20. If I can prove A is the 90-degree angle, that makes 20 the hypotenuse. And the distance from A to the center of this circle is not labeled, but since it's a radius, I know it must also be 12. Because this radius is 12. So then I can say if 12 squared plus 16 squared is truly 20 squared, I can come up with the reasoning to make that that is a right angle, because this is a right triangle, making it so that this is a tangent line. Well, if I do some math here in my calculator, I get 400 equals 400. So we can say since the Pythagorean theorem works, angle A is a right angle, proving that AB is a tangent to the circle. That's all we have to say. And again, your explanation should be down here. I just kind of talk through it. Hopefully these videos helped, and we can go through and continue with our homework and practicing for the Regents exams next week.